Okay, hey Gare, hope this goes good. This is a variable valve timing training video. This is the 2004 Honda Accord 2.4 liter. We have a variable valve timing system where Honda does on this engine is they phase the intake cam. They do not phase the exhaust cam. As you can see on the illustration, which you want to take a snapshot of, we have some components here. We have a crank sensor down by the crank. Each cam, the intake and exhaust cams, each have their own sensor. We have a solenoid, which is in the front of the engine that is duty cycled, where oil pressure acts on it, and the PCM sends a duty cycle to this solenoid to send a certain amount of oil up to the intake phaser. That's right there. And that's going to advance the intake cam, so the intake events are going to happen earlier with a higher duty cycle. So what we're going to do in this video, we're going to look at 4 signals first. We're going to look at the crank signal, we're going to look at each of the cam signals, the intake cam and the exhaust cam, and we're going to look at the duty cycle going to the VTC solenoid. It is power side switched from the PCM. So basically, one of the most important things to remember in this is when you're troubleshooting one of these systems is oil, the quantity of oil is correct. You never want to be low on oil. I added 2 quarts of oil yesterday, and that was my own oversight. That, always keep mindful that oil and oil viscosity is super important for this system to operate properly. Another thing I want to comment, this car has VTC, which is different than variable valve timing. VTC is over here in the back. I don't know if you can get that solenoid. That's a different, well, you Honda guys probably know what I'm talking about. It is a solenoid that sends oil pressure. It is reliant on good oil pressure, as is the variable valve timing. Yet what it does, it sends oil pressure up through a solenoid commanded by the PCM to the rocker shaft to get in to move a pin to latch the rocker arms onto a cam load that has a higher lift. It does that at a certain RPM, and the variable valve timing is not that system. What we're going to talk about now is phasing of the intake cam in this system. So basically, let's go to the scope. We're hooked up. We have 4 channels, and let's get locked in. And we can see that scope. That's a snapshot you're seeing there. I'm going to start the scope. We're going to see what it looks like idling and talk about it. Let me stop the scope. Now we'll start it. Now we're running, and we can see on the scope we got a fairly long time. We got 100 milliseconds. So the green, the yellow and the blue look kind of thick. The yellow is the crank sensor. The yellow is a duty cycled command to the VTC solenoid. We are idling about 750 RPM. I will stop the scope and stop the car, and we'll talk about it. So what we have here is a crank sensor in blue, an intake cam in red, an exhaust cam in green, and a duty cycle in yellow. That is an output. We have 3 inputs and 1 output. So we'll look at a fire cycle, which is 2 crank revolutions, and we'll know what we got here. Okay, we can see at this stage our cam is not phasing. Our duty cycle is not really an effective duty cycle as far as moving that solenoid. It looks maybe more like a what they call a ping signal, or the PCM maybe want to check the circuit, but basically the duty cycle is very low, not enough to get current to flow through the solenoid to phase the intake cam. So basically, let's look down at this. I'll give you a real zoomed in shot, and you basically see that's not much of a duty cycle. I don't know if that's maybe 1 or 2%, but anyway, that will change when we phase, and the intake cam, which is in red, the events of the intake cam will happen earlier. So intake valves will open earlier and it will close earlier. It will be moving this way. Let me kind of get a still shot of that. And right here. Okay. In blue we have the crank, and in red we have the intake cam. So the red will actually be going this way when we phase. So let's look at a test point, see if you can measure some degrees. Basically, if we look at our signature notch, our skinny notch on the crank, we got two normal sized notches, and then that's where the intake cam is. So if you take a look at that, take a snapshot of that, and look when we do start to phase, when the yellow starts to increase the duty cycle, that's a command from the PCM that the oh boy, okay, all right, okay, my bad. Okay, the yellow signal will move this way. It will move to the left on the screen, which is the bottom of a scope is like a clock. This is a time, and this is earlier than this is. So the event will happen sooner as the engine, as the duty cycle increases and the PCM commands the intake cam in a different spot. So here we go. We're going to start the car, and I will get the RPM up and get the load up, and we will take a look at the phasing aspect. Okay, I'll start the scope. Looks like we're running. Okay, let me stop the car. Okay, so let's take a look at our duty cycle in a certain location. Here, let's zoom in on this. Okay, now we got some duty cycle. See, that's under a load, and this is not our idle situation, which I showed earlier. And now we got some action. So let's take a look at that cam to crank relationship again. Remember where we were? We were here, and then the two notches. Now we moved a bit. Now, if we want to get some degrees, I'm going to go back and we're going to look at degrees and see what kind of improvement, what kind of advance that the VTC solenoid had an effect on the intake cam. Go back to where it's idling, and we will look at the duty cycle. Okay, right here we're kind of in that idling phase, and I want to get some cursors up so we can kind of start to measure some degrees. We don't want to just go by eye. We want to measure. Yeah. Okay, so we're going to take a fire cycle. That is from here. Let me get a little bit into here. No, okay, hang on. Okay. Okay, so we'll go from here. We're going to look at 720 degrees. I want to be at the downside of the skinny notch, which is right over here. Okay, and we'll start looking at degrees. Now, so as we measure degrees from the, let's say from the front of the skinny notch, the signature notch right here. Okay, right about here. to the intake cam, we're going to see we have a 50-degree difference. Now, I'm not saying that's 50 degrees of advance, but that's a difference. So this is all live. Nothing. We want to see what happens when the yellow signal jacks up. We see some actual duty cycle where that solenoid can move and have some effect on the intake cam. So what I've got it at now is from that signature notch on the crankshaft, the skinny notch, to the first to a downward notch closest to it on the intake cam. I'm seeing 50.76 degrees. So let's go to an area of the capture where the duty cycle is effective and did in fact advance the cam, which I have yet to prove, but we'll see if I can. Okay. Let's see what this thing looks like. We got some duty cycle. Do we have duty cycle? Okay, that looks like a pretty good duty cycle. I'm going to say about maybe 40%, 40 to 45%. And let's look at the effect. Now we'll take a capture of the of a fire cycle. That's 2 crankshaft revolutions, and see if we have more advance than we had than that 50 degrees. So here I am. I'm going to do the same thing with the cursors. We're going to go to the little skinny, the downward on the skinny knot, the skinny tooth. Another one over here, that's 720 degrees. And let's look at the distance from the downward on the skinny one to the red guy. We should see something different. 73, we are at 73.12. So that's about a 23 degree advance. So we know that the intake cam moved this way about 23 degrees. So just something to bear in mind if you ever have one of these systems where you're troubleshooting codes, or you want to just you physically see if the command took place. This is a good validation. And I'm going to add something else to it. I'm going to trade out one of my channels here to show current flowing through that VTC solenoid. So the exhaust cam, this is a situation where we can, I just turn robbing Peter to pay Paul. We want to get the, I don't really need the exhaust cam because that is a non-phase camshaft. So let me take a little change here to the scope. I'm going to put an amp clamp around the VTC solenoid. As you look at your illustration, you'll see that in the lower corner where I say rob Peter to pay Paul. So I'm going to change out the green channel. We're going to add an amp clamp. If I can get my buttonology worked out, we will add a 30 amp pico clamp to the wire from the PCM that is duty cycling. We'll see the current duty, ramp up to that solenoid. So we know the solenoid's actually pulling amperage, and it sort of validates that it's moving. So let's get that thing hooked up. Don't forget to change the channel on the scope here. Okay, get this green guy out of here. And we want to hook the amp clamp to it. So it's going to look like a different signal. We're going to see a current ramp. Let me know. Okay, so here we go. Okay, let's start the vehicle. Okay. Right now we can see our green channel. Let's put our green channel in front of yellow so we can actually make it see its effectiveness. Okay. Well, all right. There we go. I'm going to give it some no load RPM just to see if I can get that. You'll see that solenoid. You'll see that solenoid sort of ramp up and move. Upside down, my bad. Okay. All right, we can see the solenoid actually drawing amperage, which would coincide with our duty cycle. So I'm going to take one more shot. I'm going to do it with some load on it. I'm going to power brake it. I want to get a more realistic perspective of this. So I'm going to go inside and power brake it and see what we got. Let me stop the scope and we'll roll back to see where we had a rise in amperage. A rise in amperage should also coincide with a higher duty cycle. As we roll back, okay, there's a rise in amperage. It's kind of staying with, okay, right here we can see where it rose and it kind of went down because it is under the PCM's control. PCM decides how much duty cycle it wants. So right there, that's our current. Okay, that's our current flowing into the VTC solenoid at the front of the engine. As you can see on your illustration, you see that thing, that's VTC solenoid, that's got the oil pressure going through it and up into the intake phaser. And that duty cycle is PCM controlled. So basically right here, we know we have an advancing cam. Just by mere fact of, we know we have current here, we have a shift in our intake cam. Our action is happening sooner and relative to what it does at idle. So I'm going to just go back to show an idle shot of the cam and the intake cam to crankshaft correlation. Right there you can see it. Kind of freeze it, take a snapshot with your phone or something, and I'll roll it back to idle to see the difference. So we are I'm going to say 2.5 notches right there. So let's see what we look like when we are, okay, now we're back to idle. And obviously our actions are having a different spot. The cam is actually phased back home to its idle position. Our duty cycle is practically non-existent, and our amperage is low. So as far as this video, this is a really good way to validate that our variable valve timing is working. And hope you enjoyed it. I will come back with a part 2. I'm going to do something else very similar to this. But anyway, thank you. And Gary, hope you're doing well and have a good trip, my friend. And I'll talk to you soon. Bye-bye.